Hey everyone, I'm Dave Sexton. This is my fourth video in my series of videos on reactive programming. And in the previous video, I did not leave you with a challenge, if I remember correctly, so we're going to get right into it in this video. So one thing that I've been doing, which I wouldn't normally recommend, obviously, when building an app, anybody who's done it the way I've been doing it knows the problems with this approach, and that is to say I prefer a designing from the outside in approach and building from the inside out. And the reason why is because obviously if you've ever built an API by designing it from the inside out, you build the API and then you go to use it and you realize you built the wrong thing. So you may have wasted most of your time, or all of your time in the worst case, and we want to avoid that. But in this video, the reason why I didn't start from the designing from the outside in is because typically you would start from, say, the presentation layer and then move to the outer shell of the business layer, which is where I started from, and then move to the service layer. Or if you have different teams, obviously you could do things in parallel. But you start from the presentation layer because you usually get a mock-up or something, and you want to build an app that is actually useful and will work the way you want it to. And you might go through multiple iterations of that. So it's not about getting it perfect on the first try. You will make mistakes and so on. But you want to get a general sense of the design of the application that you're actually trying to build. And then you can move to the next layer, for example, like the business layer, and build out the requirements as reactive queries like we're doing here, and then communicate with the presentation layer. The reason why I didn't start this video series with that approach is because it's focusing on reactive programming. So I wanted to make sure that I focused on reactive programming first, so the video series would be more interesting. But it was inevitable. We're going to have to build an interface at some point, obviously. And you may have noticed so far, I haven't even tried compiling this code yet. It's likely there's issues with the code, which is fine. I mean, we'll fix them as we come across them. But we're not going to even get a chance to fix them or even a chance to notice them if we don't have some way of executing the code. And for that reason, I think it might be good to now take a step back and start designing from the outside in. And I'm not going to focus on aesthetics at all. I don't really care. I just want to build an interface that's functional for the purposes of building, solving reactive problems, right? Any problems that are in the reactive space. And there will be many of them in the presentation layer. We still haven't even gotten to the service layer. So there's a lot to do, and I don't want to spend a lot of time focusing on making a beautiful interface, so the graphical interface, that is. So I don't really care about the graphical part of it. I just need something that's functional. So I think in this video, I'm going to take a step back from the reactive stuff to everyone's dismay, but it had to be done, and I'm going to try to build some sort of graphical interface that maybe in subsequent videos we could start to actually hook up to what we've done in the business layer thus far, even though those are just the basic steps. We haven't done anything related to chatting yet, but we've done something related to, connecting to a service. And then we could start mocking the service layer. We don't have to actually design or even build that out yet, but we could start mocking that out just so it's running in proc, and we could start building more of the business layer out, because that's really where I want to focus most of the time, is building out these business rules. But I don't want to build the whole thing and just to discover that we built the wrong thing, right? So I think at this point I've done enough on the reactive side. I'm going to step over to WPF and build a desktop application, and I don't know if it's going to take the whole video, but we'll see. So let's, I'm going to close some of these windows first, and maybe we should review the spec again real quickly. So startup, I'm not going to worry about any of this yet. Obviously, we'll have to get to this at some point, but for now, we don't have to care. So connecting to the server. So this is the stuff we already built as part of the the outer shell of the business layer. So that was kind of our design. Maybe we should start building the UI that would correlate with this. I think that would be smart. And then anything that gets changed, okay, so be it. We'll have to go and change the business rules in the business layer to accommodate the interface that we actually need. So for example, we built all these observables that represent inputs, but what if that's not really the shape of the input we actually want, right? So this is why you should really start from the outside, designing from the outside in. I like to build it from the inside out, though. I should probably point that out, because you run into the same problem, but in the opposite direction, right? You have this beautiful design, and then you start building the app from the outside in, and you get all the way down to the deepest parts of the app, you know, the business logic and you know, where things have to be saved, data has to be saved in the formats and encoding and stuff like that, and you run into these issues where you can't solve those problems, or you have to now change the design. The app doesn't work the way, as it's not going to be as beautiful as you thought it would be, because you have to change some things, you have to work around some problems and so on. So I like to design from the outside in, but build it from the inside out, right? Once you have the design at the higher layer, in our case, the presentation layer, graphical interface, we jump down to the business layer, and then we design that, then jump down to the service layer, design that, and then start building from the inside out. You know, let's make the service work. Where do we have to persist our data, right? Where does our data come from? What's the format that we want? You know, that kind of thing, and a whole bunch of other questions around that. And then you could start building that, and then once you have that working, it makes it much easier to build the business layer. You actually have integration tests you could write, and so on. So let's build this WPF app here. I think I don't have a project yet, right? So let's create a new project, and we'll call it chatui.desktop, because we may have other versions in the future. I don't know that I'll be building them, but I don't expect this app to be all that useful anyway. It's not going to be a competitive chat application, most likely, but the point is that it might be useful from an educational perspective to actually build out a UI on, like, targeting a mobile platform or even web or something. So having multiple projects might be in the future of this application. So let's see, chat UI desktop is good, but we're going to make it a WPF app, and we'll target the latest version of .NET at the moment, 4.6.2. And did I say source? I did say source directory, right? Yeah. So it'll be next to the chat folder, which is our chat project, which is our business layer, or at least the primary project of our business layer. We might end up adding more projects to this, but we'll see as we go. I have no real thought process around that at the moment. And we're going to add a reference to chat, and then I'm going to go to my package references on the solution level and just make sure that, installed packages. We're going to make sure that System Reactive is also part of the UI desktop, right? And I guess we might as well go ahead and add value tuple as well. Package reference, yes please. And value tuple also. And we don't need the net standard library, because that's for net standard libraries, which is going to be this project here is a net standard project. That's why it's in this list. But our WPF project obviously doesn't need to reference a net standard library. So that looks pretty good. We'll save everything. And now just some small changes here for usability purposes. The title of the window is going to be, we'll just call it, how about RP chat? Okay. And then we'll have the Windows state, Windows startup location will be manual, Windows state will be maximized. That's not always the most useful, but I think for now that's going to be useful for us while testing, but we could always change that in the future, obviously. And was there any other Windows stuff? Windows style, we'll just leave that as a normal window with Chrome and everything, and a border. Okay, so here's our window, and this is the code behind. Actually, let's not even get to that yet. Oh, we also have to think about whether we want MVVM. Obviously, at some point we will. If the app becomes complicated enough, it would make sense. For now, I'm probably just going to use code behind, because there's no real advantage to having a view model, except, well, that's not entirely true. Okay, so I don't want to waste too much time explaining WPF. I just want to kind of get through this. So I'm not going to explain as much as I would if this was a reactive programming problem. So I'm just going to go ahead and start building this out. The first thing we obviously need here is a place for the user to set their username before connecting. Oh, you know what I want to do, though? The main window may be sort of a view that contains other views, if we want to look at it that way. So, for example, we show a start screen where you log in, but you don't have to necessarily see the whole chat window and everything, right? Or your contacts or anything, if we ever, you know, have that as a requirement. I'm not sure if that even is a requirement. But instead, I think it might make more sense to just show like an initial startup screen where you have to log in and specify all the details that we have here, like service URL and so on. And then if it succeeds in connecting, then that screen could go away and show another screen. So we might have to deal with navigation at some point. Also, potentially a reactive problem that we want to solve with a reactive query. But for now, we're going to definitely need separate views. So at the very least, I'm going to create a folder called views, and we're just going to add one view right now, which is our startup view. I guess we could call it, let's make it a user control, so all of the user controls could be embedded in the window. I guess we can call it startup, but I'm not sure I like that. Maybe connection. Okay, I like that. So it's our connection view. We could also put view as a suffix. It's in the views namespace. That's sort of redundant, right? Oh, it's not redundant if, well, if we have a connection type, maybe in the business layer at some point, which seems unlikely though, then you'd have to deal with namespaces in order to differentiate between them. So that could be annoying. So maybe I'll just be consistent here and use view as a suffix for all of our views, just to be safe. As a matter of fact, this is going to be such a simple app. It's likely that we will have maybe something called user view, which we have user type already. So it would make sense because there's only going to be a handful of types. There will probably be some conflicts there. So I'm okay with just using the suffix for that reason. Oops. Okay, so here's our connection view, and does that change? Yes. All right, that looks good so far. And we're going to just add the connection view as the first thing here. I don't see why not. We're going to need a namespace here called views. And that's the one. And there's our connection view. So I'm just going to do it this way because I don't see any reason why not at this point. We'll deal with navigation later. And connection views, we no longer need the main window because connection view is going to do all the work of the presentation for connecting. And let's see what we need here. So I'm not doing a split screen for this because there's just not a lot of room, especially when we're doing graphical stuff. I think I like to be zoomed in a little bit, and actually we're not even zoomed in all the way yet. And we're already split screen here. I guess we could do vertical split screen here, but then we have this editor on the side. All right, I'm just going to go with it. I'll just switch back and forth. There's not going to be much switching, I don't think so. All right, the user can set their username before connecting. So username is a string. We need a text box for that, right? And we need to, we could use bindings. Actually, if we have a view model, it's nice for that purpose. We could, all right. It's, my intuition keeps pushing me towards just doing MVVM, but I don't want to waste time doing something that's really going to be unnecessary for now. But why not just build the app the way you probably would want to build it in real life? That's the whole purpose of this example, right? So, okay, let's just use view models for this. So what view model would we want in this case? We're connecting, so connection might be a nice type to actually have in the business layer. But again, see, this is why designing from the outside in makes a lot more sense, because if we have a connection type, then inputs as usernames and service URLs as separate observables doesn't quite make sense. We're just going to pass in a single connection object, which has all the information you need, right? And then business logic for validation could just happen internally in that type. So you end up moving more object-oriented in that sense, right? So I guess for that reason, I don't want to move too object-oriented anyway, even though I want to do what's right, what's the most intuitive and the easiest to maintain, whether it's reactive programming or not. So I don't want to force reactive programming in places where I wouldn't do it in real life either. So I want this to be a realistic application, of course. But I also don't want to focus too much on object-oriented stuff. So maybe a connection type here isn't the right approach yet, but we could have a view model for it anyway. So maybe no business type backing it, but we'll have a view model that we could use for now just to represent all the data as a single object, and then that will be broken apart into separate observables. I'm actually not totally opposed to doing that anyway. If there's no reason to have a business object for this, then there's no reason for it. If the business layer doesn't really need it, and if it doesn't make sense, then we don't have to do that. So, although I did say I wanted to design from the outside in, right? I'm kind of building from the outside in at the moment, but that's okay. Let's just do this one thing here. Connection view model. Oh, actually, I want to create a folder for view models first. Okay, and then we'll add connection view model here. But this is why I was just going to go with code behind, right? We have a connection view and a connection view model. It's not going to be much different than just using the code behind for connection view. So this is the circular problem I'm getting into, where I'm trying to balance how do I make this educational and fairly quick, because I want to get back to reactive programming. Yet I also don't want to do it a way that I would think would be not as maintainable. So this approach feels better to me, but it's also pretty unnecessary at the moment, right? I'm not going to be taking any advantage of the fact that this is separate. I could just use the code behind it, it's the same thing. Because we don't even have a business object or business model, if you will, that we're representing as a view model, right? We're just basically extracting the backing type from this into a separate class. So what really is the benefit of this? I'm not sure exactly, but it feels right, because this is you want to be consistent anyway in these kinds of patterns, I think. And all right, I guess it's likely we will probably have a connection type at some point. I wanted to let the reactive program drive that, though. The only reason why I'm building an interface now is because I want to actually I want to build, first of all, compile the program at some point, and then actually start hooking up the UI so I could, push data through this program, this reactive program, and we can start seeing the benefits of it, actually by seeing it work. So that's important to me. I guess because that's my goal, I don't really have to focus on making the presentation layer designed properly just yet. I just need to design the user interface components that capture the data we need, like the user input, so that we have events that we could turn into observables, etc. So for that reason, you know what? I've talked myself out of this. I've talked myself into it and then out of it again. We will have this at some point, I'm sure. But for now, I want to just keep things a little simpler. No need to complicate things with bindings to other types and so on. We're going to just stay purely in the view. And it's such a simple app that I'm not sure that this would really be such a bad idea anyway. I wouldn't be totally opposed to it anyway. But I'm sure eventually we will start using view models, because there are other problems to deal with, right? Once you have that separation and you have reactive programming problems to deal with in the presentation layer, how do you get an event from the UI pushed through to a view model, where the view model doesn't have any knowledge of the control that it's the data context of, right? So that becomes its own sort of problem that you have to deal with. So it makes sense. I'm gonna have to do this at some point, because I want to show how I would solve those problems. But for now, I want to just get something done simple in the UI so we can hook it up to the business layer. All right, that was a boring 10-minute circular problem-solving session. I think I'm happy with this decision, so I'm just going to go with this. I'm going to go with it. So I'm going to make this a data context that's bound to itself for now, and we'll use bindings, but I'll just be binding to the code behind. So the text is going to be a binding to, that's one of the benefits of a view model, though, right? Because then INotifyPropertyChanged is available to us right away, where here I'll probably have to use dependency properties. Yeah, that's not as nice, is it? Ugh. Yeah, there's really no good shortcut here. I'm just going to go back to view models. I knew this was going to happen. I'm not going to stop and re-record this video, because this is exactly the kind of thing that I deal with on a daily basis when I'm building applications, right? So this is realistic. Making these weird decisions, then you make the next step and you notice that it was a bad decision. You make the next step, you notice you have another bad decision. And I could just sit here thinking ahead, but then I'm not going to be talking, and that's going to be even more boring for you, so the listener. So I'm just going to go with what I originally thought felt right to me, and there was a reason why this felt right, and I'm just going to go with it. Now, I'm going to keep it simple though anyway, but this makes the most sense to me for now. So now we'll have our view models here. I'm not doing this in any way that's going to be complicated. I'm just going to create an instance of the view model as a data context explicitly here. I'm not suggesting necessarily this is the way you would normally do it in an app. This is good enough for starting this app, right? So we're going to say data context is view models. An exception has occurred. Wonderful. I wonder which component that was. I don't know, but I'm not going to find out. And that's going to be our connection view model. Okay. And I didn't compile it yet, that's why it's giving this error, I'm sure. But Once I compile that will go away. So now we'll do a nice binding to a view model, and I don't have to implement INotifyPropertyChanged. Not that it's difficult, but I wanted to avoid this stuff. But forget it. It has to be done at some point anyway. Why not just do it now? So the binding is going to be to the username property, which we don't have defined yet, right? The user could set their username before connecting. Perfect. So text box with the username in it. That didn't take long, did it? It took about 10 or 15 minutes to get a text box with a binding in it. All right, this is usually pretty easy, but now let's add that actually before we do anything else. So we're gonna have a username property, getter and a setter. Actually, we're gonna have to implement this anyway. I'm gonna have a base class. I'm gonna go ahead and just create it right now because we're gonna need it anyway. It'll just take a second. It's gonna be an abstract base class, and it's gonna implement INotifyPropertyChanged. Oops. Let's implement that. Public void. So here, I'm just going to create a little, property changed. Oh, you know what? Here I'm going to do it as a string, right? Caller member name. Yeah, there it is. So here I'm just going to create a little method that we could use to raise a property changed event for a particular property, because this is going to be the most common case also. And that's going to call in a base on property changed method. Not use block, generate method. This is going to be a protected virtual method, which is going to say property changed. Invoke, where E is going to be a, let me just move this to the next line. Property changed event args. Okay, that looks good. And on property changed, we can now create a new property change event args with the property name. Come on, there we go. And I also like to create another one here where takes nothing, and we call it, say, like raise any property change or something like that. And you can just pass in null here. This is actually important because it's more efficient a lot of the time. If you have a lot of property change events that you're raising in WPF, every property changes, it all raises, each one raises its own event. It's way more efficient just to say if multiple properties changed, then just call raise any property changed and raise it, the change event, with a null value for the property name. That's a special value that WPF treats as any property changed potentially on that type. Okay, so that's raise any property changed, raise property changed, and now we're going to want a setter, which could be protected. I wonder if I should make these protected as well. I'll make these protected for now. I'll make them public if we need them to be public. I doubt it, but keep everything protected just in case for now. So this will be property void set T. And this is going to be our little helper method. I mean, anybody who's been doing WPF development is familiar with this pattern. If you've been doing development in other platforms, I'm sure you're familiar with the pattern that I'm doing, even though this may, the actual implementation may look a little unfamiliar to you. This caller member name, if you're not familiar with it, the C# compiler, when it sees this attribute, implicitly sets the string value here, whatever this name is irrelevant, whatever the string parameter is, it passes an argument for it that is the name of the caller, which could be a method or a property or whatever. So that way you could omit the parameter yourself, and the compiler will specify it for you, which is really nice. It avoids all those magic strings that you end up having in your application for raising property change events with where you have to specify the property name. You'll see that in action in a moment, obviously. So here we're going to say this is going to be a field. Oh, it's going to be a ref to that field though, and then the T value. Right? And then also the caller member name for the property. So here we could say, we're going to have to expand this, I think. If, let's see here, compare of T. Let's do it this way. So if the field equals the value, actually we want, if the field does not equal the value, oh, and usually I like returning a bool from here, I forgot. So if the field doesn't equal the value, then it's been set, so we're going to return true. And to set it, we just set the field equal to the value. This is a ref, so it's going to update the actual field with the value, not just this argument in this scope. It will be external to the scope. And otherwise, we're going to return false because the values are already equal, so there's no reason to do the set. And we could use this Boolean to do other, other decisions outside of this method. Okay, that's pretty good. Probably good enough for now, I would think. Oh, I forgot one of the most important parts here, which is raising the change event, right? So if the field is equal to the value, we raise the property changes event and then return true. And it's not on property changed, it's raise property changed, right? Although I think this should probably just be called on property changed too if it's protected. I like to use raise if it's external. I don't know why. Just, I guess, the way I'm used to designing it, but probably not all that important. Okay, 1 second. Okay, sorry, I just took a moment there to fix the microphone because I think it was dropping a little bit and it looked like maybe the audio was too low. So I apologize if the previous section, the audio was too low. But anyway, we'll continue from here. So the field is the value, on property changed, property name, return true. This looks good. And these say on now, but we can have a public one with raise if we want to go there. Okay, so that's the view model. I'm happy with that for now. And, oh, did I want to make anything else virtual here? Nah, just this one. These both call into this one, so only this one needs to be virtual. And I don't like making this virtual. It shouldn't be, I don't think. It's doing something very specific. Okay, so now we have to actually raise change events for this. So there's a nice new feature in C# where we could do this and say, username. I don't like using underscores, so we're going to do it like this. So there's our field, right? And for the setter, we could say set ref username to value. Value is passed into our property. All right, so this looks good. Let's go back to the view. We have a username. You know what? Actually, maybe we should just try building it for now, because that way we could use the designer a little bit. And our business layer might actually fail, but that's okay. We'll just fix whatever bugs are in that as well. Oh, that's right. I never implemented this enum because I wasn't sure if I'd even need it yet. So you know what? I'm just going to go ahead and comment this out just for the moment, because in the future when we get back to that, if we need that enum, we'll implement it. But who knows what's going to happen. Oh, that was the only compiler error. Very good. So now we have our designer back, and we now have a view model and a text box with a username. Okay. What else do we need? We need a username, and the user must enter a service URL. And then click a connect button. So we need a service URL box and a connect button. So that's going to be another text box. Call this service URL and a connect button, which we will, come on. Set the content to connect. The underscore is an accelerator for the C key, whatever key follows it. So if you press Alt, we'll underscore the C as an accelerator. And then also useful for accessibility. And then here we'll say the text, not the text, the command. Sorry, we already have the content. The command is going to be a binding to some command type, which will be, in our case, something called connect. All right, that looks good so far. And let's just finish up with this by actually organizing it a little bit so we could see all the controls in this grid. So let's see, I'm thinking text box layered on top of each other with a button, all horizontally centered for now. We're probably going to want a label as well, so let's add some labels. Label, what is it, content? Yeah, content equals username. That looks good to me. And then here we'll have service URL. And we'll set the target to binding element name equals username. And target here is going to be for service URL. And then now we have to add a name for these so that the target can find them. This just makes it so if you click the label, it focuses the control. Nice little feature that most people are used to when using Windows. It's not absolutely necessary. I find most programmers don't do it. And what else we have here? I think that's good enough. So let's organize this now. We're going to have some row definitions. We want, let's say, 3 rows. And this is going to be the first row, second row. And we're going to wrap this in a, we could do a stack panel. Let's do a dock panel, right? And the label is going to be docked to the left. We'll do the same for this one. Dock panel left. Oop, Visual Studio's frozen. Oh, there we go. I don't know what happened. It was loading for a second. Dock panel. Okay. And now let's set our rows here. Row is 0. This is going to be 1. Oops. Ah, come on. And this is going to be 2. Or 2. And there we go. And now let's make these vertically aligned. This one's going to be to the bottom. This one's going to be vertically aligned center. And this one's going to be vertically aligned to the top. And I like to set the widths of my buttons explicitly. In this case, I don't think we have to set the height just now. And then this height will be auto. Alright, that's pretty good. And we want these to be lined up a little bit, right? Let's just set the width of this to be, I don't know, 100. That looks good. Text alignment. Oh, no text alignment in a label. Horizontal alignment, right. Oh, no horizontal alignment. Horizontal content alignment is right. Yeah, there we go. And we'll do the same thing here. It's getting a little bit lengthy now. Alright, looks pretty good. And then just some margins to clean it up a little bit. By the way, I should have pointed out, I don't like using the designer. Most of my experience is in writing the XAML, so for the whole series, you'll see. Well, probably not going to do much XAML work anyway, but I'll be doing it all by typing it. So I hope you're okay with that. Some people like to use a designer. I'm just not used to it. I think as programmers, most of us are probably used to just doing it through XAML anyway. But I like having the designer visible while I'm doing it. It makes it a little easier, right? So you don't have to keep compiling and running and so on. Okay, so anyway, margin, I don't know, 5. It's usually my default margin that I always throw in there is 5, and then I adjust from there to see if I want something different. And then this will also be 5. All right, looks pretty good. Good enough, I guess. And no background, but I'm okay with that. It's going to inherit the background of the window. Remember, this is just like a screen or whatever that's going to a sub-view that's going to be inside of the window, so we could set whatever background we want in the main window. And that will just be used for all of the screens. Okay, so that looks pretty good, I think. And we have to implement connect and service URL in the view model, right? I created a view model, yes. We don't actually need the code behind it all. All right, you know what? I'm glad I did it as a view model. Maybe I was just lazy before. I was trying to avoid it. I had some pretty good reasons for not doing this, I guess, but I'm happy with it now. This is the right way to do it. So, this is going to be a string service URL for now, right? Obviously, well, in the view model, it's always going to stay as a string, but at some point, we're going to start dealing with it as URI once we get into the service layer and the business layer. Okay, so what are we returning here? We're going to have a field. We already have that. Yep. Service URL, set ref, and value. All right, that's pretty good. And now the connect button was the only remaining thing here. And that we require an ICommand implementation. So we're going to have to implement one of those, which is fine. We shall do that. So let's add a using statement for command and connect. Now, designing from the outside in, right? This is the important part here. We don't want to go and build this, ICommand implementation and then go ahead and try to consume it. We want to consume it first from here. What would be the ideal thing we want to write here? So, we want to be declarative or simplistic at the very least, and then we'll just implement that. Whatever it takes to implement that, we'll do it. So here we know we have to implement this ICommand interface. So the ICommand interface requires an event handler that you don't have to actually implement it, but it's only useful if your can execute function will ever return a different value than the previous one. So the WPF will query this, pass in whatever parameter you've bound to, or null if you haven't bound a parameter to it. If you return true or false, it will either enable or disable the button based on that return value. And then if you want to change that value at any point, you raise this event, and WPF has already registered an event handler for this event, so it will be called back, and WPF will then invoke your canExecute method again, and if you return a different value this time, then it will change the enabled state of the button to match whatever your return value was. And then, of course, when the button's clicked and it's enabled, because canExecute, at least the last invocation of it, is return true, then it will invoke your execute method. Now, what's interesting about this interface is that it's coupling two things that normally you wouldn't need to think that you would couple. Execute really represents like a click event. It doesn't have to be just for buttons. Obviously, ICommand can be used for other purposes, but in general, if we're thinking in terms of just buttons and commands are just buttons, then execute is just a click event, right? There's nothing really to it, except it also has this additional parameter. But okay, fine, that's allowable. With a click event, there's no button. There's no parameter attached, but it's nice to have as a discrete thing here. Fine. If you wanted to get the parameter out of a button click event, you would just have to figure out some place to put the parameter. You could use like the tag property, for example, on the control or something like that. But having a discrete way of doing this like this is nice. So it's nice to have an interface where the button supports the interface, and instead of calling click, it knows how to call execute. And the parameter, although I didn't show you in here, comes from just another property on the button. You could say command parameter. You could bind that to something else, whatever. So it's a nice way to get data through your click event, but it's represented as a explicit function in an interface rather than just a separate event, right? But then it pairs this interface, ICommand, pairs that with this concept of can execute, which is really weird, actually, right? It's really only useful for controls that care about disabling being disabled, right? Or so having an enabled state or a disabled state based on whether or not the command is available at that moment or not. And coupling them together turns out to be fairly useful, actually. So as a pattern in presentation layer programming, GUI programming, having a command that interface that couples the two is useful, but it's a little strange, right? And also the fact that you now have this weird event sort of attached to it, it's not as simple of an interface as you probably would have guessed had you not known about this interface before. You probably didn't guess that there would be some sort of event handler on it, or if you did, you would have thought it would have been more like a click event, but it's not. It's just for raising a change that this property, that this function will now potentially return a different value if the caller invokes it again. So it's a bit weird, right? But if we look at this from a reactive perspective, we could see that, again, like I said, this execute method is like a click event. Well, you might click the button multiple times, right? And each time you click it, you might pass in a different parameter if there was a way to pass in a parameter. Here we have that. So it's almost like an IObservable, right? It's like the IObservable with a parameter being pushed into it, the parameter being the data or the T of the IObservable interface, the IObservable of T, where T is the generic type argument. The parameter, it's just a untyped parameter, data that you can pass through the observable and push through the observable, I should say. So why not maybe model this as an IObservable? Maybe that's useful for us. Maybe when we're dealing with converting our user interface input into business layer input, having an IObservable from events that are being represented not as events but as commands would be useful. Now, this may seem also a little strange that we have to do this, and it's because WPF, and as far as I know, pretty much every presentation layer platform for building GUIs nowadays isn't designed with reactive programming in mind. It's designed with events, But those are sort of the object-oriented way of dealing with reactive problems, right? It's not reactive programming because events aren't composable. We could have a million events, but we still have to register or add a handler to them, and then that gets invoked back, and it's either it's going to be a Lambda or some imperative-style program that then has to deal with state in some way, and then you have state somewhere, and then how do you correlate that with another event? Well, you have a field, where you store your state, and then another event gets raised, and you check the state in that event, right? So it's not composable, it's not declarative, it's not the direction we want to go in. So it's not reactive programming. It's the reactive way or the reactive model in the object-oriented world, strictly remaining object-oriented, right? So we have delegates that get called back, but they're just pointing to methods or functions that exist on some type somewhere, and everything's stateful and explicit and imperative. And it is push-based, right? Because raising an event is a push-based action, but it's also multicasting, right? It's pushing to every handler that's been added. So this is like the hot programming model in the reactive world. But this is not always what we want. Actually, much of the time, it's not what we want at all. While we're building queries up, we don't want to necessarily have everything published, right, all the time. Some queries we just want to have side effects when you subscribe. So having subscription side effects can be very useful. So for that reason, having events as the reactive model in an object-oriented world sort of pushes us in the wrong direction. So a lot of people tend to use events a lot because it feels like you're going in the right direction, but you are, I guess, but you're not quite getting there, right? To get to reactive programming, you have to shed the events, right? And the way to do that is to convert them directly to observables, but you can't avoid the fact that you're still dealing with hot observables at that point. We don't actually have to implement the event at all as an observable because we don't really care about this event. I mean, it's very rare that you're going to want to subscribe in the presentation layer yourself to CanExecuteChanged events. Sometimes you do, but most of the time you don't care. Most of the time this is just WPF subscribing to this event. And again, the reason why this is the case is because WPF was designed around events and around objects as data contexts, view models and so on. So it's more about object-oriented programming, and the reactive part of it is events, but they're not really reactive in the way we're learning about it, right? The way we're trying to go with reactive programming. So WPF makes it harder for us. We have to adapt. So we have to create these adapters between all these mechanisms that WPF wants to use or forces us to use. And they're nice. They're nice in the object-oriented world, but they're not exactly what we want. So we'll just have to deal with it. We'll have to create our own adapters for these things. So the first one we're going to do is ICommand, and obviously execute's going to be an observable. We may or may not need to create an observable for event. Maybe we'll just do it anyway because why not? It'll be our first event to observable conversion, so it'll be a good learning experience, but we'll probably never need that. And WPF doesn't care that we've created an observable out of this. It's going to always use the event because that's all it knows about. And then CanExecute. Well, again, it's another thing that we could represent as an observable, but it's probably never going to be something that we're going to have to subscribe to ourselves. That's more like WPF caring about invoking this function in order to get the latest value, but WPF's never going to subscribe to our CanExecute observable, right? So for us, again, it doesn't. We probably won't need to implement this as an observable either. So for that reason, I think I'll skip the observable for this one, but we'll do the observable for execute, and why not? We'll do an observable for CanExecuteChanged as well. So we're going to need an ICommand implementation. Because it's sort of our reactive version of it, let's just call it Reactive Command. I actually have one of these in RxX, the Reactive Extensions library. I don't remember what I called it. It might be called, I think it is called Reactive Command actually. But I wrote it a long time ago. I don't know that I haven't used it in a long time. I always write my own every time I need to in every application now. It's not the best idea, but I don't want to take a huge dependency for something that's, as you'll see in a moment, is quite simple. And I very rarely interact with other libraries that need to have a reactive command that's shared. So, implementing my own for every application seems to make sense. Anyway, that's why I tend to just implement it myself every application. And internally, and when you're working for a company, maybe you build your own for that company and then just reuse that across multiple projects. That's fine too. But I don't know of any public one that I would like to use. Actually, there's also a reactive UI library out there. I've never used it though. It's designed, I believe, for WPF focusing on WPF and with RX as a dependency and specifically with RX in mind. So I'm sure it's great. I just never use it. I prefer to just, a lot of the stuff is pretty straightforward and pretty simple. I like to just build it myself. And RxX has a few of those already built as well, but I don't even depend on those anymore. So anyway, that's my 2 cents on this. So reactive command, we have to implement this. It's going to be an ICommand. That's, oops, I'll just let Visual Studio generate this. And now, can execute. We will return a field. Oh, sorry. I don't like using underscore, but I use them at work because that's the pattern we use. So I'm just so used to doing it. But when I code at home, I still just do it without the underscore. Again, this is subjective, so who cares, right? You do what you want. But this is the way. This is what I prefer. So can execute will be a. Actually, do we want to make this read-only? That doesn't quite make sense because we're going to want to be able to change it probably as well. Yeah, so I'll leave that as not read-only. So let's create a constructor first of all here. And this will take in a function that takes an object and returns a Boolean. And this will be the can execute function. So this way we can create a reactive command by passing in a function or a lambda expression or whatever we want, which would make this much easier than having to implement ICommand as a type every time. We could just remain a little bit declarative here, right? Oh, didn't I say I wanted to I wanted to build this from the outside in? I wanted to, excuse me, design this from the outside in, and then here I go again, building from the, you know, it's so easy to fall into this trap, but I always remind myself, no, go to the outside and design it first. So before I do this, I have experience doing this, so I know what I'm going to want, but just as for, I guess, didactic purposes here, I'm going to go back to the view model and actually describe what I think would be the ideal way to implement a command from this position. So what I'll do here is then, what I'd like to see is reactive command dot, oh, actually, no, we could just use a constructor here, new reactive command. Yeah. That's probably good enough, actually, for now. And normally you pass in the execute method or can execute, but we don't actually need any of those. We just want to convert this right into an observable. And that could be done by the reactive command type itself. So we don't necessarily actually need to specify the execute function. Yeah, so I think this is good enough. Now, the only other thing that we might want to do here is not create this on every time the getter is invoked, which is what's happening here. This is a property with a getter. This is just a getter that's read-only, no setter, right? But every time you read this property, it's going to create a new reactive command. So that's obviously not what we want in this case, because we're going to have to subscribe to the observable at some point. We're going to have to do something with it. So we want all subscriptions to be, part of a single instance of this reactive command object. So we're going to use this syntax here, which allows us to create, again, a read-only anonymous, or rather automatic property, right? But with a default value of new reactive command, okay? And then because it's a read-only property, it's creating a read-only backend field, which means it can only be set once. So this is a very nice, clean way of describing exactly what we want here, which is a ICommand implementation that cannot be changed once this connection view model object is constructed. So we construct an instance of this type with the new reactive command object as the connect property. And now we could subscribe to the connect properties observable once we actually define it for other purposes in the future. So this is pretty nice. Now, if we go to reactive command, now we see that this was the benefit of designing from the outside in. We probably would have ended up doing a bunch of stuff, which I know eventually we'll need because I've done it before, but right now we don't need it. So we can keep things simple and just do exactly what we need. In this case, we want a constructor that takes no arguments. As a matter of fact, we don't even have to define it then. We get one for free because it's a class. So this works. The compiler's happy. We can create a new reactive command. However, we know we're going to need an IObservable implementation as well. You should never implement IObservable yourself. As a matter of fact, you should never even really implement a type that derives or implements IObservable in even an indirect way, except for the fact that sometimes you have to, but you really don't have to. So what I mean is, if you find yourself doing it, then you're probably doing something wrong. It's almost guaranteed that you're doing something wrong if you're doing it. It's very rare where you need to implement IObservable yourself. Okay, notice we did the whole business layer in the first 3 videos, not the whole business layer, but we did a lot of it in the first 3 videos. Did some complicated queries, did some publishing. Nowhere did I implement IObservable, right? And nowhere was I going to implement IObservable, except for the fact that here we have no choice. Okay. Again, we're building this bridge where we have this ICommand interface that needs to also implement IObservable, right? This is the simplest path to building an adapter between what WPF requires and what we require in our business layer. So it's not that we want to do this, we just really have no choice here, okay? So this is one of the few places, very few places, where it makes sense to implement IObservable. If you find yourself doing that, you're probably doing something wrong, okay? So here I'm going to do it, and again, never implement IObservable yourself. Instead, use observable base, which is, if you ever have to do it, which you should never have to do it, use observable base, because observable base is the RX's implementation of IObservable for you. It's an abstract base class that provides some of the complexity around satisfying some of RX's contracts. However, it doesn't satisfy all of them. It's not thread safe. So RX requires threads, serialized notifications, and observable base does not guarantee that. So again, it's another reason why you should not implement IObservable yourself. Even deriving from observable base is not going to get you all the way where you need to be. You're still going to have to understand that you're going to need to synchronize notifications yourself. The reason why it's going to be very safe here is because we're going to have a little implicit contract here. I just let it generate this method for me, but I'll implement it in a moment. But we're going to have an implicit contract here that states that the reactive command can only ever be used from the UI thread. So we get serialized notifications for free. That contract in RX is satisfied for us automatically. But it's not automatic. It's only automatic if we actually satisfy the contract of this class, which is that it can only be used from the UI thread. But, you know, that's going to be something that we're not going to necessarily be able to enforce programmatically, unfortunately. We can put some contracts that verify that it's on the UI thread in every method. So maybe we will do that. So you can technically enforce it, but it's not something that people tend to enforce, unfortunately. So I like to use code contracts, but I don't want to go off on a tangent with code contracts. So in this video, I might not do that. Maybe I'll just throw them in anyway because it's easy. But the point is that it's dangerous to implement IObservable. And if you can't guarantee that you're going to satisfy RX's contracts, even though this helps you to satisfy the RX grammar, but only if you satisfy the RX serializability contract, then if you don't satisfy that contract and you build an observable that's not thread safe, you're going to run into a lot of nasty threading bugs, and it's going to be very hard, very difficult to debug your application. So avoid implementing IObservable unless you really know what you're doing. So once I've done this, although this is sort of in contrast to the way I've described Reactive Command being something simple that I always implement myself, right? But I'm used to it. I've done this many times. So I guess you could take the code that I put in here and start with this as a solid base for yourself, or maybe there's other Reactive Command implementations out there that you prefer, which is fine as well. But maybe unless you really know what you're doing, you shouldn't actually implement Reactive Command in all of your applications separately. I apologize for giving you bad advice there, but I'm just so used to doing it myself that it's hard to remember the reason why you shouldn't. There's that. Okay, so anyway, now I want to actually implement this thing. So subscribe core is actually the observable base abstract method that we have to implement, but it's really called subscribe, right? IObservable has a subscribe method on it, which gets passed in an observer, and we have to do something with the observer. This is also one of the reasons why you don't want to actually implement observables yourself, because what do we do with this observer now? Now we have to be stateful and hold a reference to an observer. It just becomes a mess, right? But we're going to have to deal with it because WPF, unfortunately, wasn't designed with a reactive programming model in mind. And now if we want to use that, we have to build the adapter ourselves, right? So how do we do this now? We have to do something with this observer, so we'll do something with it in a moment. Let's see what we want to do with execute. With execute, we know execute essentially just means invoking or pushing a notification, right, through an observer. But what if we have multiple subscribers? We're going to do something with multiple observers. So technically, we need like a list of observers. What's different now is that we're going to just composite a subject. we're just going to create a new subject of object, call it subject, why not? And now that's how we'll implement our subscribe method and our execute method, right? We'll just forward to the subject. So it's the same thing, right? We could have just derived from it in previous versions, I think, but this is fine too. It doesn't really matter. It's the same result here, right? And then for the onNext, we just have to call subject.onNext. All right, so there you go. Sorry for the little runaround here, but I'm so used to just building it and not explaining it, right? So in this case, we have subscribe core and execute just forwarding to the subject. Now, can execute's sort of a different animal altogether, but in our case, we're just going to hard code true here because we have no reason not to. There's the only usage of this at the moment is a parameterless constructor that we just want notifications when WPF calls execute. Anytime any observers that we've have subscribed to the subject will be pushed to notification through onNext, right? So that's good enough for us, right? Sealed. Oh, sorry, I meant to say read only. Duh. So we don't need this backing field either. Oops. For can execute. And that's good enough for now, right? It's a pretty simple adaptation from the WPF world to the reactive world, with a lot of confusion mixed in. Sorry about that. But I think we've finally landed on something that actually is good for our purposes. It's simple. It's going to get more complicated, right? In the future, we're going to be adding more stuff, obviously, to this. We're going to be building up this type to do more things, but for now, I think this is good enough. Okay, so there's our reactive command. So now this looks good, reactive command, and we can, just as an example here, if we call connect, or excuse me, if we read the connect property, you'll see that we can now call, why can't we call subscribe on it? Oh, the type here needs to be reactive command as well, right? And now we call dot, we see the subscribe method because it's an observable. Now if we add a using statement for system.reactive.link, we see that our connect property is now also a observable that we can use extension methods on. So we have all of the operators that Rx has defined available to us to compose over this. So hopefully you see where this is going now, right? We're going to be able to write some nice composed declarative Rx queries in our presentation layer as well in order to form the inputs for the business layer. And then also likewise, we're going to take the outputs from the business layer in the direction of the presentation layer as inputs into the presentation layer, coming from a different direction, to form additional queries that will then generate output for the GUI, right? Like a message coming through that ends up getting added to a list box or something, right? Or a flow document or whatever. So that's going to end up happening obviously in another video. I think we've gone on long enough for this video, but the essence of what we've done here is actually pretty much what we're going to be repeating over and over again, building interfaces in general, right? So you have some property, you raise a change event by calling the set value. Oh man, Visual Studio is not doing well for me today. I don't know. All right, anyway, so you have properties which are almost always read-write, you know, unlike a business layer where you'll want to keep properties immutable if they can never change. In the presentation layer, you're almost always dealing with, actually I shouldn't say almost always dealing with, you might also have read-only properties, right? But you might have a business type where you want it to be immutable. It makes more sense for reactive purposes. I don't think I've even mentioned that yet, but we'll get into that at some point as well. But in the UI layer, you're almost always going to want getters and setters, and everything's read-write because you're dealing with bindings and user input. It's dirty. You haven't validated it yet, and so you just accept any input that the user sends your way, and the setter will call a function called, in our case, called set, which will raise a change event, a property change event. And WPF can react to the change event, whatever. And we're going to have an observable for that at some point as well, which we'll deal with, I think, in the next video. And then we could form queries from that we could pass to the business layer. And for functions that deal, behaviors in the application. So this is like sort of handles the state of the UI, right? For behaviors in the UI, we tend to deal with things like ICommand implementations. So our reactive command just adapts that into an observable, and then we're back into the reactive world on at least on our side, right, of the in the view model layer, or the view model objects in the presentation layer. The GUI is still going to deal with its own ICommand interface and its object-oriented world stuff, but we've adapted so we don't have to deal with that in our code. So this is the common pattern that we're going to see a lot more of as we continue to build up the UI and add more view models and more features. So I can't really think of anything, any challenges to give you for this. I think if I did, because we didn't really do anything reactive here, except, we built a reactive command, but we didn't really use it. We didn't form any queries over it. So I think that I'm probably not going to issue a challenge for this video either. It would be more WPF oriented, which I don't know, maybe interesting, but not really the point of this series. So thanks for watching.